Hello everyone, and welcome back to my videos. We're on to mock set 3, paper 3, the last paper in the set and another calculator paper. As always, please like and subscribe if you enjoy these videos, if you find these useful, and I'll put timestamps in the description so you can skip to whichever question you need me to go over and need the walkthrough for. Okay, right, well without further ado we'll get stuck in and get started. Okay, question 1. Okay, I would say quite a nice straightforward question to start off with. 168 as a product of prime factors. So I'll go with trying to figure out which colour pen I use. I can't remember now on these videos. Right, 168. So split that up into 2 times by half of 160 is 80, half of 8 is 4, so 2 times 84. 2 is prime, so circle that. Bring that 2 down. I'm doing that so that each line of my working is going to be equal to 168, and I've circled 2 because it's prime. 2 times by 42, and again circle the 2 because it's prime. Bring my 2's down, my prime numbers down, times by, and 42 is 6 times 7, I know that, so 7's prime, circle it, and then my last line is 2 times 2 times, and now 6 is 2 times by 3 times by 7. Now each line of that working out is equal to 168, which is why I keep bringing those prime numbers down, and you can do it to check. 2 times 2 times 2 is 8, times by 3 is 24, times by 7 should give me 168, and I can check it on the calculator. Yes. Okay, now products of prime factors, you can write it as 2 times 2 times 2 times 3 times 7, or I can write it as 2 cubed because it's 3 2's, times by 3 times by 7. Okay, find the highest common factor of 168 and 180. Now I need to, for this, the ideal method that I would suggest is to use a Venn diagram. And then you're going to put in your factors of 168 and 180. Now I know my prime factor decomposition of 168, so I can use that from up here, but I haven't done it yet with 180, so I need to work that out first of all. Well, that is 2 times by 90. Bring my 2 down. 90 is, well, that's 9 times by 10. Neither of those are prime, so can't circle those. And then 9 is 3 times 3, which they are prime, and then 10 is 2 times by 5. Again, both of those are prime. Okay, now I've got in here, I've got 2 2's, so 180 is 2 squared times 3 squared times 5. 2 2's, 2 3's, and a 5. Now I need to put these in my Venn diagram. In the middle needs to go the prime factors in the prime factor decomposition that are in both. So I've got 2 2's here, I've got 3 2's here. So I can put 2 2's in the middle, and then I've got 2 3's here, 1 3 here. So there's only 1 3 that's in both because I don't have 2 3's in this one. So 1 3 in the middle. There's 1 5 there, there isn't a 5 here. There's a 7 here, there isn't a 7 here. Okay, so the only ones that are in both are well, 2 2's and a 3. Now we can fill the rest of this in, although it's not necessary for this question. 168. So to make up the 168, I've got in this circle already a 2, a 2, and a 3. So I need 3 2's, I need another 2. I've got the 3, and I need a 7. And then for the 180, I've got 2 2's in the middle. I've got 1 3, so I need another 3, because I need 2 3's in total, and I need a 5. Now the highest common factor is the biggest number that we can divide both of these by, and so the way to find that, if it's got to go into both things, is, well, it's got to be the middle. It's these middle numbers multiplied together. So highest common factor, HCF, is 2 times 2 times 3, which is 4 times 3, which is 12. Okay. Right, question 2. Eric and Geraldine both drove from town A to town B. Okay, so town A to town B, and we've got 2 routes here. Both Eric and Geraldine left town at 2 p.m. Eric drove on route 1. He got to town at 2:48. Geraldine drove on route 2. She got to town at 3:25. Who drove at the greater average speed? Now, I know this is how I remember my my formula for speed, if you like. In Europe, they work on kilometres per hour. I know that because I've been on holiday there a few times, seen the signs. And so the way that's written is kilometres and then / hours, and that means basically kilometres divided by hours. Now that's a speed, it's a unit of speed, so speed is equal to, now that's distance divided by hours, which is a time. So speed is distance divided by time, and if you want to, from there you can put it into one of these triangles to make things a bit easier for yourself. So distance divided by time, so it's got to be distance on the top, and then one of these at the bottom has to be time, so then speed has to be the other one. Distance divided by time. And the way these work, if you want speed, cover it up, do what's left over, distance divided by time. If you want time, cover the t up, distance divided by speed. And if you want the distance, cover the distance up at the top, and you've got speed, because it's next to it, speed times time. And that saves you having to do any of the rearranging, if that's something that you might struggle with. Right, now we need to work out the average speeds for both of these. So we're going to have to use the total distance, and we're going to have to divide it by the total time taken. Now, generally, you want speeds in miles per hour. Having said that, because we're comparing them, we could do miles per minute, and then that might be easier. So, and a quicker comparison rather than having to try and change it into hours. Right. Now, they both leave town at 2 p.m. So this is 48 minutes. It took Eric to get there, and 3:25. Well, that's an hour and 25 minutes. 1 hour is 60 minutes. Add the 25 is 85 minutes. Okay. Now, because we're doing a comparison, it doesn't matter if we work it out in miles per minute, because we just need to compare which one's going quicker, basically. So we're going to do it in miles per minute just because that's easier. We need distance, so we're going to do Eric speed first of all. So Eric's distance was 36.4 miles, and we need to divide that by 48 minutes. And because obviously we've got miles and minutes in there, this is going to be miles per minute. So 36.4 divided by 48 is 0.75833. So 0.7583 ... So that's how many miles Eric will be doing per, or has done per minute. And then if you wanted to know per hour, we'll just times that by 60. Okay, so 45.5 miles per hour. Okay, and then the next one, so this is Geraldine. The distance for Geraldine route 2 is 65.2 miles divided by 85 minutes. So that is going to give us 65.2 divided by 85 is 0.767. 0.767 ... So, and that's miles per minute. So who's doing more miles per minute? Who's going quicker? Geraldine. And then I just need to write that as a sentence. So Geraldine drove, and really, if you're not sure what to write for these sentences, have a look at the end of the question. That will normally tell you, well, you know, the key part of the question. Who drove at the greater speed? Geraldine drove at the greater speed. Okay. There we go, and that's the answer there. And again, if you wanted to work out just quickly Geraldine's speed in miles per hour, well, that's how many miles she's doing per minute, so 60 minutes in an hour times by 60, and we get 46 point something. So previously it was 45.5, so yeah, a little bit quicker. Okay, question 3. Okay, this is a looks to be a constructions question. Here is an accurate scale drawing of a school playground. 1 centimetre represents 2 metres. Nassim is going to put a seat in the playground. The seat has to be less than 9 metres from C, closer to BC than AB, and more than 4 metres from AB. Okay, so we're going to need, well, you're going to need, and I'm going to need my compass for this. We've got on there, it tells us that 1 centimetre is 2 metres. So that's going to be useful when we're obviously doing the conversions. So what I'm going to do first of all is actually change each of these into centimetres so I can actually measure it on here. So 9 metres, well, 9 divided by 2, let's work that out. 9 divided by 2 is 4.5. So that's going to be 4.5 centimetres. Okay, and then more than 4 metres from B, well, 4 metres is 2 lots of 2, so that's going to be 2 centimetres. Okay, I'm going to need my ruler for this as well. Right, so we need to do less than 4.5 centimetres from C. Now, if I want it to be less than 4.5 centimetres from C, I'm going to have to do it, as in put the sharp bit of my compass on C, and I'm going to have to do like a curve that is going to be 4.5 centimetres in terms of distance from C, because that will be inside that will be less than 4.5 centimetres, which is what we want, less than 9 metres. So I need to get my ruler, and I'm going to need to set my protractor up, compass, sorry, I always get the two mixed up, so it's 4.5 centimetres. So I've got my ruler here, and I need to set my compass up, so it's 4.5 centimetres. Right, so, and you've got to make sure this doesn't move. What I would do is obviously check it at the start, do it, check it at the end. Right, so I've got my 4.5 centimetres, I've measured it on my ruler. I'm going to put my the sharp end of my compass on C like I had before, and you want to get it right in the corner, make it as accurate as possible, and then you want to kind of hold that bit in place with one hand. It's a bit tricky, and then I suggest kind of leaning your compass a little bit so that you can make this curve nice and easily. You're not putting too much pressure on the pencil by pushing down on it and then potentially moving it. Okay, and there's my curve. So it's a bit difficult to see because I've done it in pencil, but you can see it there. I might just go over the top of it again just to make it a little bit clearer for you. Okay, so inside that line is where I want. Now what I could do now is, and I'll use my pencil to do this because it would just be easier. So I want basically inside of this. I want to shade the area in a second, which is going to satisfy all of these conditions, but I want inside of that because I want less than 4.5 centimetres, less than 9 metres from C. Closer to BC than to AB, so closer to this line, so closer to BC, this line, then to this line. Now the way to do that is I'm going to have to bisect the angle, essentially cut the angle in half. Now there's a couple of ways we can do that. As we've got the compass out, we shall use the compass to do it. So the way to do this, we need to basically cut this angle in half, and if you've got a protractor, you could do it by measuring, because you know that's going to be 90, so you know, you could just measure out a 45-degree angle. If you don't have that, you can do it with your compass. So the way to do this is obviously, well, put your compass out into some kind of distance. It doesn't matter as long as that distance stays the same. This doesn't have to be a particular distance. So I've got it set at a distance. So I'm now going to intersect this line here, and I'm going to intersect this line here. I'm going to cut across it with my pencil. Okay. Now when I've done that, I'm going to pick the pointy end up and I'm going to put it down on where those two lines I've drawn intersect with the sides of the shape. I'm going to do that, and then I'm going to do a curve, an arc, roundabouts where I think it would intersect. So when I put now my pencil on the other bit, I'm going to again do an arc, and where it would intersect, so where both arcs intersect would be the line that's going to bisect. So basically the point I'm going to put my ruler through to bisect the angle. Okay. Okay, now I've got this point here is where those two curves intersected. So I'll go through what I did there again, because it's a bit tricky if you haven't seen it before. So set your compass up to any kind of width. You then cut through one of the sides. Okay, you then cut through another one of the sides, making sure it stays the same width apart. You then pick it up, you put the pointy bit on where you just intersected the sides. You draw an arc. Doesn't matter how long it is, but it's got to intersect when you drew another arc from the other point. Okay, that intersection point is the bit you need. Now you can see it's intersected here. So what I'm going to do is I'm going to grab my ruler and I'm going to put it from obviously that corner to the intersection line, so or where those two curves intersected. So here. Now it needs to be closer to BC than to AB, so I'm going to draw on that line like that. So that is, oh, it's not quite perfect, let me just correct that. And this is why you do it in pencil. I think what's happened is I put a pencil down and the ruler's shifted it. That's better. Okay, so now it needs to be closer to this line BC than AB, so again I'm going to use my pencil and draw on the arrow, so it's now going to be inside of this line. So I've cut out that kind of well, that segment there. Right, so that's that bit done. Then more than 4 meters from AB, so it's got to be more than 4 meters, which is more than 2 centimeters from AB. Now 2 centimeters, measure it up. So 2 centimeters. Now I'm going to use my pencil again. I'm going to have to get a pencil out of my compass. So 2 centimeters from AB. Now that is here, and then the other 2 centimeters is going to be, make sure I'm measuring this right, here. Just put a little mark on, and then I can join those two lines up. Okay, now it's got to be more than 2 centimeters from AB, so now I'm looking at this bit down here. Okay, and you can see from where all the arrows are pointing that the bit I now want is this shape in here. Basically a kind of trapezium looking shape with this arc at the bottom. So it's going to be this bit here. And when you're doing these sketches, when you're doing the shading, it doesn't need to be Mozart, it just needs to be, you know, in the right areas. So it's, you know, it's obvious who's marking it. Okay. You need to have all your construction lines there so they can see what you've done. Okay. Next question, question 4. There are only red counters, blue counters and green counters in a bag. Okay, so the number of red counters to the number of blue counters to the number of green counters in the ratio 1 to 3 to 7. A counter is going to be taken at random from the bag. Complete the table below to show each of the probabilities that the counter will be red or blue or green. Now probabilities, we can have either fractions or decimals. Now if we add our well, the parts up, so the total of our number of parts in our ratio, 1 add 3 is 4. 4 add 7 is 11. So in total we've got 11 parts. 1 out of the 11 is red, so we could write this down as 1 out of 11. Blue is 3 out of 11. Make sure you check with the wording up there, but yeah, it is blue, 3 out of 11, and then 7 out of 11 is green. And that's that bit done. Jamie takes at random a counter from the bag and records the colour of the counter. He then puts the counter back in the bag. Now that's important because there's replacement there. This isn't a conditional probability. Question. Jamie does this a number of times. He records a total of 68 blue counters. Okay. Work out an estimate for the total number of times Jamie takes a counter from the bag. Now approximately we would expect 68, and you can do this a couple of different ways actually, because we've got the fraction, we've got the ratio up here. So 68 blue. Now you could say 68 is approximately, well, it's 3/11ths. Okay, so 68 is 3/11ths of total. Okay, so we would expect that if these probabilities were completely accurate, they were completely right, that if he was to, you know, take out these counters completely randomly and mix them up completely randomly, that 3/11ths of the time he would get a blue counter. Okay, so therefore 68 has to be 3/11ths. If we now divide 68 by 3, we will get 1/11th. Okay, so 68 divided by 3 gives me this not particularly nice number. So 68 over 3, which I leave it as a fraction, is 1/11th of the total. If we then times that by 11, okay, we've got this number, 249.3. So 249.3 is 748 over 3 is 11/11ths of total. So the whole we would expect. Now obviously when I typed, or when I had that number on my calculator, 748 divided by 3, that's not particularly, well, it's not a nice number, and it says work out an estimate. Okay, it's an estimate really for a couple of reasons. It's an estimate because this isn't exact. You know, it's when you do an experiment, the experimental probability, the you know, the actual results you get aren't usually, you know, vast majority of the time are not the theoretical outcomes, the theoretical probability. It's not what you would expect exactly. That's because it's an experiment, and you know, there's an element of chance involved. So you know, it's an estimate because we're assuming that this is going to be exact, which we know it's not going to be, but it's our best estimate. Now also it's an estimate because, well, you can't have taken 249.3 counters out, so you know, the best guess we could say, because it's a lot closer to 249 than 250, is 249. Okay, it's a total number of times he takes a counter from the bag. Now, as a way to check, we could split 249 into this ratio. So 249 divided by, well, 1, add 3 is 4, add 7 is 11, divided by 11, times by, now it was blue counters, wasn't it? So blue was the 3 parts in the middle, times by 3, and we get about 68, very, very close. Okay, so our best estimate, our best guess is 249. Okay, moving on, question 5. Okay, Mariam is trying to expand and simplify m minus 2 squared. Here is her working out. So m minus 2 in brackets squared is m minus 2 times m minus 2. N times n is n squared. Minus 2 times n, or negative 2 times n, is negative 2n. Negative 2 times n is negative 2n. Negative 2 times negative 2 is not negative 4. It's supposed to be positive 4. So Mariam's mistake is this negative 4 part here, and we've just got to say that now. So Mariam has multiplied negative 2 and negative 2 and got negative 4, which should be positive 4. Okay, Josh is trying to factorise x squared, subtract 6x plus 8. His reasoning is because 4 times 2 is 8 and 4 add 2 is 6. Then x squared subtract 6x plus 8 is x plus 4 and x plus 2. Explain what is wrong with Josh's reasoning. Well, we don't want these numbers to add to make 6. We want them to actually add to make negative 6. So it should be negative 4 and negative 2, or x subtract 4, x subtract 2. Okay. So explain what is wrong with Josh's reasoning. Josh needs two numbers that multiply to give 8 and sum, or add, and add I'll put to give negative 6. Josh's numbers add to give positive 6, not negative 6. It's always good with these questions when you're explaining what's wrong to explain what they should have done. So, and by what I mean by saying should have done is what numbers they should have used. So he should have got x minus 4, x minus 2. So it's always good with these to give actually the right answer. Okay, and then that's that question done. Oh no, it's not, sorry. Jumped the gun a bit there. It's part C. Shona has to draw the line with the equation y equals 3x plus 2. Here is her line. Explain why Shona's line cannot be correct. Well, we've got a positive gradient, 3x, and this is an increasing line. It's a positive, it's a line with a positive gradient. But the next bit, this plus 2, that's the y-intercept. Now that tells us where it intersects with the y-axis. Now because that's positive, this intersection point shouldn't be below 0, it should be above. Okay, so Shona's line cannot be correct as her line has a negative y intercept, and it should be at positive 2. Okay, next question now, I think. He says, question 6. Right, work out the size of angle KLM. So we need this one here. Now I notice these are both right angle triangles, which should be helpful. I've got one side, but I don't have anything else yet. So I need to work out another side for this MKL triangle. So what I can do with this MJK triangle is, well, I've got two sides here, and to work out the third side I can use Pythagoras. So 4.5 squared add 7 squared, add them because we're working out the hypotenuse, i.e. opposite your right angle, and then we're going to square root it, and that has got to be equal to MK. Okay, that line there. So square root of 4.5 squared add 7 squared, and that gives me 8.3216. So I'm going to just 8.32 ... or if I press S to D, root 277 over 2. It's always good writing that down in the third form, or the exact form I should say, so that if you lose that number you can just plug it back into your calculator and you won't get a rounding error if we use this, root 277 over 2. Okay. Right, so this one really is root 277 over 2. Now we need to find this angle here. Now with right angled triangles, I've used Pythagoras, I also know I can use trigonometry. So angle KLM is equal to, now I've got the opposite side and I've got the hypotenuse. So opposite and hypotenuse. Now if you do remember this acronym, SOHCAHTOA, that's fine. It's a way of remembering which one you need to use. So we've got, like I say, the opposite and the hypotenuse. Opposite and hypotenuse is sine. So sine of my angle, so I'll just write it down here, sine of, let's call this alpha, just so we've got a reference for it. So sine of alpha, sine of my angle, is equal to my opposite, so root 277 over 2, over, and then my hypotenuse, which is 15. Now obviously once we got this part, we're very close to being there with our answer. What we need to do now is basically inverse sine both sides. Just moving it over so you can see it clearer. Inverse sine both sides, and that will give us the angle. So actually angle KLM is going to be equal to sine, inverse sine, sorry, sine to the negative 1 of root 277 over 2 over 15, and that will give us our answer. Doesn't look particularly nice, but it doesn't matter. So shift and sine for inverse sine, fraction button. Now I need another fraction on the top, so fraction button again. Square root 277, go down 2, go down again 15, go right, bracket equals 33.695. And we wanted the three significant figures, so 33.7 to three significant figures, degrees. I'll try write it down here as well. Okay, there we go. Question 7. Liquid A has a density of 1.42 grams per centimeters cubed. Now immediately I know this is a density question, it's quite obvious. What I want to do is actually write down the equation for density, and like with speed, distance, time, these units here kind of give it away. So density is equal to grams, which is mass, mass divided by this is a volume. Centimeters cubed is a volume. Okay, now again you can put that in your triangle to save you having to do any rearranging. So density is mass divided by volume, so mass on the top divided by, and then volume you can put either side, left or right, doesn't matter which one, and then density has to go in the other one. So that will help us if we need it. Right, now we've got here, even just looking at the question before reading it properly, liquid A, liquid B, liquid C. We need to find the density of liquid B. Let's read the rest of it and figure out what we can do here. Just the type of question this is, even though before reading it though, it reminds me of a question I've seen previously where you've got three of them, there's some combined density, some combined volumes and masses, things like that, and so there's quite a bit to work out. So what might be useful to do is to do a table, just to put all of the information in and to keep track of what we've worked out. Okay, let's read it and let's see. So 7 centimeters cubed of liquid A is mixed with 125 centimeters cubed of liquid B to make liquid C. Okay, so in total we've got, what is that, 132 centimeters cubed for liquid C. Liquid C is the density of this. Find the density of liquid B. Okay, so like I said, best thing to do here is to do a table, and we can do A, B and C. There are liquids, and we can do mass, volume, density. Kind of like a two-way table with it, I suppose. Right, let's start putting the information in. It's similar to a two-way table in the fact you've got lots of information, but obviously you don't work it out by adding and subtracting things. Liquid A is density of 1.42 grams per centimeters cubed. So density 1.42. 7 centimeters cubed of liquid A is mixed with 125 centimeters cubed of liquid B. So 7 centimeters cubed of liquid A, that's the volume, so 7 of this. 125 centimeters cubed of liquid B. Add those together to make liquid C, which is 132. Liquid C has a density of 1.05. So 1.05. Now to work out the density of liquid B, we're going to need to know the masses. Now we can work out the mass of liquid A, mass of liquid C, add them together to get the mass. Oh, sorry, not add them together, subtract the mass of A from the mass of C to get the mass of B, and then work out the density from there. So mass of A is equal to, so colour mass up, density times volume. So we've got 1.42, just make sure the units are right, grams per centimetres cubed for A, and then yes, centimetres cubed. You've got to make sure they're consistent. 1.42 times by 7, which is 9.94. Now that is going to be in grams, because if you look at your compound units, it's grams per centimetres cubed, so 9.94 grams. And then we did the same thing, so mass of C is equal to 132 times by 1.05, so 138.6. Okay. Right, now we can, and that's going to be grams as well, we can you know, add and subtract your masses and your volumes. You can't just add and subtract your densities. It doesn't work in that way, because essentially the density is a ratio of your mass to your volume, and so it doesn't work that way with your compound units. You can do that obviously with your usual units though, you know, not compound units if you like, your standard units. So we can take these two away, so 138.6 subtract 9.94, what does that give us? 138.6 take away 9.94 is 128.66 grams. Okay, and then density, 128.66, density of B is equal to, density is mass divided by volume, so 128.66 divided by 125, and see what that gives us. So take my answer here, divide by 125, and I get 1.02, and I want it to 2 decimal places, 1.03. 1.03, 2 decimal places. Okay. And there's our answer. But you can see how this table helped to kind of just keep track of what we've got and then what we can work out. Okay, next question. Kira used her calculator to work out the value of a number x. She wrote down the first 2 digits of the number on her calculator. She wrote down 7.3. Write down the error interval for x. Now, the error interval, usually what you can do is, you know, basically you can, if it's the decimal places, go 1 decimal place down, 1 decimal place up. Sorry, let me say that again. If it's, say, it's been rounded to 1 decimal place, you go, you know, in the second decimal place, you go, sorry, you would end up going half a decimal place, so, you know, let me give you an example. It's easier to me to give you an example. So, usual example. This is usually what it's like, ignoring this question. Okay, so 3.7 is correct to 1 decimal place. What's the error interval? Now the error interval is going to be, well, if it's correct to 1 decimal place, go 1 decimal place down. And the way I do this is with a number line. So 1 decimal place down would be 3.6. 1 decimal place up, 3.8, and you want to go halfway in between those. So 3.65, 3.75. So my error interval for this made up question here would be x is between 3.75 and 3.65. That's usually what these types of questions are like. I'm just going to box that off because that's just an example. So you can do it in that way usually. Now in this case we can't, because of the way it's been done. Now just going back quickly to this example, it works because obviously lower than 3.65 would go to 3.6 to 1 decimal place, and bigger than 3.75 goes to 3.8 to 1 decimal place. But if you're lower than that, it will round to 3.7. Okay, so basically when you think of the lowest number and the biggest number that we could have in this scenario. So she wrote down the first 2 digits of her answer. So we know these first 2 digits are correct. Okay, we know they're correct. Write down the error interval for x. So the smallest number it could be actually is 7.3. And the biggest number it could be is 7.3999999999999, which would be less than 7.4, anything less than 7.4. Now I have actually got to go back to this example and just change this. It could be equal to 3.65, can't be equal to 3.75, has to be actually less than that. In the same scenario, we're going to have for here, x has to be less than 7.4, and it's got to be greater than or equal to 7.3, because it could be 7.3 for all we know, but it can't actually be 7.4. It can be anything less than that, but it can't be 7.4. So that would be the error interval in this case, and that's because basically what she's done and why it's different is she's essentially truncated her number. She's cut off all the rest of the digits and she's just written down the first 2. So it couldn't be less than 7.3. Okay, right, there we go. Next question, question 9. Okay, right. On the grid opposite, draw a cumulative frequency graph for this information. They've given us a lot of space here, considering actually we're using the graph on the next page. I'm sure somewhere they could have made that a slightly bit smaller so it would have fitted, but it doesn't matter. We have to do a lot of going backwards and forwards here. Right. Now, we've even got the cumulative frequency here. Now, the lowest value here is 20, so we're going to put a cross on 20. Okay, so we're going to start at 20. You should be doing this in pencil, but obviously I'm doing it in pencil, you can see it a bit better. We'll actually do it in red for this. So I'll go back 20 here. Right, now, by the time we get to 30, we've definitely had 10 below 30. So we're going to put a height of 10 at the age 30. Okay, so that's going to go here, and we go back. Now at 40, we've definitely had 26. So we know there's definitely 26 below 40, and obviously above 20. So 26 on 40 is what we're going to plot. And then 58 were definitely below or equal to 50. So on 50, we're going to plot 58. So on 50, go up to 50 and then 8. So it's going to be here. And then turning back over. At 60, we definitely had 66. So plot 66 on 60. And then finally, we've got 70 less than or equal to 70. That's right at the top there. And with the cumulative frequency curve, we need to do a smooth curve through our points. I'm just going to use my pencil for this and try and make it as easy to see as I can do. So it's got to be a smooth freehand curve. Do not do straight lines. Should go through all the points. And you've got to do your best and make sure you use a pencil, so if it does go wrong, you can correct it. Okay, so there's our freehand curve, and everyone's will be very slightly different, but it should be pretty much the same, near enough. Your point should definitely be the same, and then it's just your curve which will be slightly different. Use your graph to find an estimate for the median age. Now, for the cumulative frequency, it goes from 0 to 70. Okay, so what we need to do actually is we need to half 70 because the median's in the middle. And we're going to go across along from half of 70, which is 35. So go along from there. and then when we touch the line, that's when we're going to go down. So mine is about 44. That's the estimate for the median age for me. Everybody's will be very slightly different. Okay, now Francesco says more than 60% of the people in the office are between 35 and 55 years old. Use your graph to determine if Francesco is correct. So we want 60% of the people in the office between 35 and 55. Now we can find an estimate of the people that are between 35 and 55. What we need to do is, just like before, get our ruler, get our pencil. We're going to draw lines up from 35 to our curve and then go across. I'll do it in the pen again so you can see it properly. So 35 and then go across. So I reckon that's going to be there. So that is 17. And then 55, go up and then go across again. And when you get to your line, you want to go across. So that is 62. Okay, so we've got 62 to 17. So that means essentially below 35 is 17 people. Below 55 is 62 people. So we need to do 62, take away 17, and see what that gets me. 45. So we've got 45 people that are between 55 and 35. Now, what we then need to do is work out if that is more than 60%. So, in total, we've got, if we just go back, 70 people, because that's our total for the cumulative frequency. Okay, so we need to do 60% of 70 is, so 0.6 times by 70 is 42. So, is Francesco correct? Yes, Francesco is correct, okay, because we've got 45 people between 55 and 35, and 60% is 42. So, by our calculation, by our graph, there are more people that are, well, more people than 60% of the total are between 35 and 55. Okay, you'll need your working out there, and what you might want to also write is 45 is greater than 42, just as like a mathematical statement. It's just stating the obvious, but it's just to make it perfectly clear. Okay, next question. In a sale, the price of a TV is reduced by 25%. A week later, the sale price of the TV is reduced by 15%. The price of the TV is now £293.25. What was the price of the TV before the sale? So we've got some number, and if it's reduced by 25%, as a multiplier, that's timesing by 0.75. The way I work that out is this is 100% take away 25%, which is 75%, and then 75% as a decimal is 0.75. And then the next one, if it is reduced by 15%, that is a multiplier of 0.85, and that's a similar method. Okay, so 100% take away 15% is 85%, and that's that as a decimal. Now, something times by those two things gives us 293.25. Now, what I can do is I can rewrite this bit, because it's multiplication. Well, actually, instead of timesing by two things, let's combine those two things and turn them into one thing, one multiplier. 0.75 times 0.85 gives me 0.6375. That's equal to 293.25. Now I want to work out what this missing number was that we had at the start. So actually if I do the inverse operation and I divide, that'll tell me what it is. So 293.25 divided by 0.6375 will give me the answer. 293.25 divided by 0.6375, £460. Make sure your zeros look like zeros and not sixes. Okay, expand and simplify. This is I would say a straightforward question of the type. It's nothing that looks particularly complicated. So first thing I'm going to do is expand the first two brackets. So I'll write it out. First of all, x plus 2, x plus 8, x minus 4. So I'm going to forget about this third bracket. I'm just going to do the first two. I like to do the eyebrows, mouth and nose method, I call it. So eyebrows, x to x, 2 to 8, so there's the two eyebrows. Mouth, so x to 8, and then the nose is the inside, so 2 to x. So x times x is x squared. Then you want to do the bottom two, so 2 times x is 2x, x times 8 is 8x, and then you've got the other eyebrow, 2 times 8 is 16. And we've got all of that times by x minus 4. So we've got x squared plus 10x plus 16 times by x minus 4. Now the way I would like to, well, the way I usually do it from here is essentially I've got to times everything in here by everything in here and do it systematically. So times everything, first of all, by x, and then times everything here by negative 4. So times everything by x, I'm going to get x cubed plus 10x squared plus 16x. Okay, that's everything times by x. Now everything times by negative 4. So negative 4 or minus 4 x squared. Minus 40x, and then negative 4 times by 16, negative 4 times by 16 is negative 64. Could have done that in my head, but if you've got a calculator, use it. You don't want to make any silly mathematical kind of errors by doing things in your head that you don't need to be doing. Right, so that's everything done. Now I need to collect my like terms. X cubed, how many x squareds have I got? 10 take away 4 is 6x squared. 16x take away 40x is negative 24x, and then subtract 64, and that is my answer there. Okay, next question. Right, question 12. Just going to sort my paper out here because I've folded this completely wrong. And it's just going to make it a bit awkward, so there we go, much better. Okay, the diagram shows a metal rod AB resting inside a cylindrical tin. The tin is on a horizontal table. AC is a diameter of the base of the tin. So what I would do at this point is draw on AC. B is on the top edge of the tin. BC is vertical, so it looks like we've got a triangle in here, right angle triangle. The radius of the base of the tin is 5 centimeters. So actually, this is going to be 10 centimeters in total. The volume of the tin is 1,178 centimeters cubed. Find the angle between the rod and the base of the tin. So we want that angle in there. Right, now what we need to do is we need to work out the height, because we need this other side to then work out that angle. So we need to kind of reverse engineer the volume. So 1,178 is equal to pi r squared times by the height. So pi times by the radius is 5, so pi times 5 squared times by the height h. So 1178 is equal to 25 pi times by h. So h has got to be equal to 1178 divided by 25 pi. Type that into my calculator and see what I get. this particularly not nice number, and I don't really actually want to write that down because I'm going to have to round it if I do. So I'm going to leave that as 1178 over 25 pi. Okay, so I'll put that here, 1178 over 25 pi. It's about 15, but I don't want to write it down and round it and potentially get rounding error. Now what I need to do is I've got this right angle triangle here. So I've got opposite and I've got adjacent. So again, SOHCAHTOA. Opposite is this, and then adjacent is this. So I've got opposite over adjacent. So tan of, again, I'll call it alpha, my angle. So tan of my angle is going to be opposite, which is 1178 over 25 pi, divided by, again, 10. So inverse tan of both sides will give me alpha, the angle. Inverse tan of 1178 over 25 pi over 10. And we'll see what that gives us. Fraction button again, 1178 over 25 pi divided by 10. 56.3, wanted the nearest degree, so we're going to go 56. There we go. Okay, question 13. For any three consecutive whole numbers, prove algebraically that the largest number and the smallest number are factors of the number that is one less than the square of the middle number. What a horribly worded question, I must say. Right. Now, we need to approach this, obviously, slowly and just take it step by step. So we need three consecutive whole numbers. Let n be an integer. Consecutive means one after the other, so we can have n plus 1 and n plus 2 are consecutive. Integers essentially means the same as whole numbers. Okay. Now we need to use these to prove that the largest and the smallest numbers are factors of the number that is one less than the square of the middle number. So if they're factors, well, first of all we need to do one less than the square of the middle number. The middle number is n plus 1, so we need to do n plus 1 squared, and then we need one less than that, so take away 1 is equal to n plus 1 times by n plus 1 minus 1, which gives us n squared plus 1n plus 1n, so plus 2n plus 1, then the minus 1 there, which gives us n squared plus 2m. Now if we factorise that to give us the factors, we've got n and n plus 2. Okay, now that is n times n plus 2, therefore n is a factor, the smallest one, and n plus 2 is a factor, the biggest one. Therefore n and n plus 2 are factors of n plus 1 squared minus 1, the middle number squared, take away 1. Thus we've proven the statement. And put your square at the end and say you've done it. Okay, I'll just put it there so we can obviously see it a bit better, a bit clearer. Not sure why my camera does that. I need to get a new one which focuses actually properly rather than just focusing on one side of the paper. Okay, next one, prove algebraically the recurring decimal 0.457, where the 5 and 7 is recurring, can be written as this. Okay, So first thing to say is let x be equal to 0.457. It's the 57 repeating, so I'm going to write that bit out. 57, 57, 57, dot dot dot. And then we want to get it, so just the recurring part is in the decimal. So this 4 isn't recurring. We want to get that out of the decimal part of the number. So times it by 10. 10x is 4.575757 dot dot dot. We then need another number, which is obviously related, so some multiple that has 57 as the recurring part. So what we're going to do is actually times 10x by 100. So 10 times 100 is going to give me 1000x. So that is going to be 457.575757 dot dot dot. And then we're going to do, well, 1000x take away 10x gives me well, this number here, 457.5757 dot dot dot, take away 4.575757 dot dot dot. You can see the decimal part, the repeating part, is going to cancel out. Okay, so really all we need to do is 457 take away 4, which gives you 453, and that is 990x. 1000 take away 10, 990. It's 453. Divide both sides by 990. And we get x is equal to 453 over 990, which simplifies if you divide top and bottom by 3. And I would want to show this even though I can do it on my calculator because it's a proof question. 453 divided by 3 is 151, which it should be, over 330. And then we've done. Okay, next question, 15. On the grid, show by shading the region defined by these inequalities. Okay. What we're going to do is plot each of these if they're equal to, and you've just got to be careful about whether you do dashed lines or the solid lines. Okay. Now actually looking at all of these, we're going to have dashed lines because none of these are or could be equal to. Okay, they don't have less than or equal to or greater than or equal to. So we're going to do x is equal to 4, so that's got to go through my x-axis at 4. That's going to have to be a dashed line because it can't be equal to it. So dashed line as if it is x equals 4. And we want a less than, so now do your arrows to go less than, so you're going to the left. We want less than 4. And your arrows just help you when we've got more lines to see which section we want. Now the next one is a bit tricky because we've got x's and y's on the same side. So I'm going to rearrange this. I'm going to take away 2x from both sides. So I'm going to get y is greater than negative 2x plus 6. So now what I need to do is plot y is equal to negative 2x plus 6. So it's got to go through 6. Okay. It's then got a gradient of negative 2. So for every unit I go along, I go down 2. So I'm going to go here. I'm going to put dots on this because I'm going to go through it. So 6 here, go along 1, down 2. Along 1, down 2. Along 1, down 2. So my line is going to go, and it's going to be dashed again because it's less than or equal to. My line is going to go dashed line both directions like that. Now we want y to be greater than that. So with these ones, where you've got y's and x's, plot your line, and then if y is greater than, you're going above. If y is less than, you go below the line. So actually we want to go above here. Make sure you draw those arrows for these lines vertically. So they're either going straight up or straight down. Okay, so we're looking at this area at the minute, and then we know that the last one, y is greater than a third x. So for this one, again we've got y's and x's in there. We've got no y-intercept, so we're going through at 0. Now for every unit we go along, so every one we go to the right, we go up a third. So we're going to have to go along, if we go along one, we're up a third. Go along another one, up another third, so 2/3. Go along another one, we're up at 1. Okay. Okay, then go along one, up a third. Up another one, up to 2/3. Up another one, and we're up to 2 now. And then up one, up a third, up another one, up 2/3. So we've got a couple of points on there, well 3 points. We can make sure our ruler lines up with those 3 and then go through them, and then that will be our line. We've got to make sure it's dashed. Do it in pencil always, in case you do make a mistake and you don't do them as dashed lines when you should have done, and things like that. Now we've got that y is greater than, so again we're going for above. Okay, we want above that line. Now we need to label the region R. So the region R is here. It's above and it's inside those two. Now what you want to do when you've done that is pick a point and check that it satisfies all of these conditions. If it does, you've done it right. So let's go with something like, let's go with one that's definitely inside. Let's go with here, which is 2, 5. Okay, so x is 2, so x2 is less than 4, that works. 2 times 2 is 4, add 5 is 9, that's greater than 6. And then y, what do we say? Y was 5, so we've got 5 is bigger than a third times 2, 2/3. Yes, it is. Okay, so we're done. There we go. Okay, next question. Okay, there is a large number of cubes in a bag. Jason wants to work out an estimate for the number of cubes in the bag. He takes at random 10 cubes from the bag. He puts a mark on each cube and then puts each cube back in the bag. Now this is sounding an awful lot like a capture-recapture problem. Okay, he shakes the bag up and then takes at random 20 of the cubes. 3 of the cubes have a mark on. So 3 out of 20 have a mark on. Work out an estimate for the total number of cubes in the bag. Now, assuming these cubes are being mixed up totally and it's totally random, we want to know how many times he would have to do this to get all 10 cubes, okay, that he initially put a mark on. So how many times would he have to do this to get all 10 with a mark on? So 3 out of 20 have a mark on. What would we have to multiply 3 by to get to 10? Now that's a bit tricky. What you can do on your calculator, if you do have some, you know, not the easiest numbers like this, is just do 10 divided by 3. That gives me 10/3. So times by 10/3. Okay, and we're going to do the same on the bottom. Times by 10/3. So 20 times by 10 over 3. It gives me 200 over 3. 66.6 reoccurring. So 66.6 reoccurring. Work out an estimate for the total number of cubes in the bag. So again, estimate, we're going to go with 67. Okay. And we'll just check that to make sure I haven't missed anything in this question. There's a large number of cubes in the bag. It wants to work out. Random 10 cubes in the bag. Puts a mark on each cube, and then puts each cube back in the bag. Checks. Yeah, okay. Because if you were to take out 20, you'd expect 20 of those 76, you'd expect 3 of them to have a mark on them. Yep. Okay. Because you got 10 out of 67. 10 out of 67 is about 0.149, and then 3 out of 20, 0.149, 0.15. Okay. It's about the same, about equivalent. Okay. Usually those will be whole numbers and not decimals like that, so you won't have to do any rounding. So I'm a bit surprised that is a decimal, but it is what it is. Okay. Right, 17. At the start of year n, the quantity of a radioactive metal is Pn. At the start of the following year, the quantity of the same metal is given by this. So basically this means the next year is 0.87 times by the previous year. At the start of 2016, there were 30 grams of the metal. What will the quantity of the metal be at the start of 2019? So 2016 is equal to 30 grams. 2017 is equal to 0.87 times by 30, which is 26.1 grams. 2018 is going to be 0.87 times by 26.1, so times by 0.87 again, and we get 22.707 grams. So 2019 is 22.707 times by 0.87. Sorry that I've swapped those numbers around there, I didn't do that on purpose. So times by 0.87 again, 19.75509. It wants the answer to the nearest gram, so that is going to be 20 grams. Okay, next question down here. Here is a sketch of the curve y equals sine of x plus a in brackets plus b. Now what I want to do here is I actually want to draw or sketch out my sine graph. So I know it starts from 0, goes up, and it does like an oscillation like this. So this is going to be at 360, in the middle is 180, goes up to a height of 1, gets down to a height of -1. We've got 90 here and 270 there. Okay, let's just move it over so you can see it. Okay, so that's my sine graph, that's what it usually looks like. Now I've got to think about how do I get from that to this. Now obviously it's going to have been shifted along in some direction. It's also been shifted up or down. Now there will be probably, it says that alpha is between 0 and 360, so it's got to be positive. Okay, now right, we will think about alpha in a second. What would probably be easiest to look at b, because that's going to affect our y direction, our height. A lowest or a minimum for the sine graph usually is -1. This gets down to -2, so we're going to have to shift our graph, the whole graph, down by 1. Now when you're adding or subtracting something outside of your general function, so outside of the sine function, it's not in the bracket, then it behaves in the way you would expect it to, and so b is going to have to be -1 because we're shifting the graph down by 1. Now when it affects the x value, it does the kind of inverse or the opposite of what you'd expect. So this says x plus a. If we add something onto a, you would expect, your intuition tells you that it's going to go up. Well, actually it does the opposite. So if we have x plus 30, for instance, that means that it would actually take 30 degrees away, and it would go left 30 degrees rather than what you might expect is go right. Okay, because obviously that's affecting your x direction. It's not going to, if we have x plus 30, it's not going to add 30 to our x direction. It's actually going to move it left by 30 degrees. Now what we want here is, obviously you can see this point here at the top, this peak, that's at 90. We need to get that from 90 to, on here, 0. We've already shifted it down, so that will now be here, it'll be on 90. We need to get it from 90 over to 0. So we want to basically shift it left by 90. We want to subtract 90 in the x direction. Now, like I said before, it does the opposite of what you'd expect. So we don't want to actually take away 90, and we can't do that because a's got to be between 0 and 360. We want to add 90. So a has got to be 90. So what we end up with is sine of x plus 90 and then -1. So that will shift it left 90 degrees, and then this will shift it down by 1. Okay, next question. check how many questions there are in here. So we've got 19, 20, 21, 22. Okay, nearly done. Okay, question 19. The diagram shows triangle ABC. AB is 3A, AC is 2B. B to E is 3 of AC. Well, AC is 2B, so 3 lots of that. 3 times 2 is 6, so that's going to be 6B. And you can underline vectors. There's lots of different vector notation, but one of them is just underlining your vectors. Obviously, I can't draw it, or I can't write it in bold like they've done in the text. Okay. D is the point on BC such that B to D to D to C is 3 to 1. So B to D is 3 to 1. So that's 3, 1, total of 4. So 3 quarters, 1 quarter. Right. Now, prove that ADE is a straight line. What I need to do, if it's in a straight line, they need to have a common point and be parallel. So parallel means essentially multiples of each other. So what I need to do is I need to work out A to D and A to E. A to E is the easiest, first of all, so A to E, and actually the longer one is usually the easiest because you're not going to have to do any fractions. So A to E is going to be 3A add 6B. Okay, now I need to work out A to D. They've got a common point of A, so as long as they are a multiple of each other, so A is a multiple of AD, then it will work. I can also write AE actually as 3 lots of A plus 2B. That will work. Okay, now to AD. Now AD is going to be, well, I can do it as AC plus a quarter of C to B. So A to C, so AC, so along this way, plus a quarter plus 1 quarter of C to B. Okay, and that gives me AC is 2B plus a quarter of, well, C to B is minus 2B plus 3A. So minus 2B plus 3A. Okay, so we get 2B, a quarter, so negative 2 times a quarter is negative a half, so negative a half B. A quarter times 3A is plus 3 quarters of A. Collect your like terms, so we've got 3 quarters of A, I'll put that at the front. 2 take away a half, or 2 add negative a half, is going to be 1.5, or 3 over 2. Okay, so I've got 3 over 2B. Now I need to show that it's a multiple of this, or sorry, this one is a multiple of this one, essentially. There's some multiple. Okay. Right, now, got 3A plus 6B. What we can do is I could, again, kind of factorise this out. So I could take, if I take 3 quarters out of the front, so 3 quarters out the front, so 3 quarters of A plus, now 3 quarters times 2 is 6 quarters, which simplifies to 3 over 2. So actually this is 2B there. And if you don't believe me, do 3 over 2 divided by 3 quarters on your calculator. Okay, and I'll just fill this bit in here. AD, 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 AD. So, as A to E and A to D are both multiples of, I should really say both integer, no, not integer, no, I'm not going to write integer, it's not integer because that's 3 quarters, both multiples of A plus 2B, they must be parallel, as they also can't write, also have a common point A, they must lie on a straight line. Okay, so it's the key point is a parallel and they've got a common point. Okay, question 20. Okay, another question about counters and things in bags. There are 9 counters in a bag. There is an even number on 3 of the counters. There is an odd number on 6 of the counters. 3 counters are going to be taken at random from the bag. The numbers on the counters will be added together to give the total. Find the probability that the total is an odd number. Okay, now what we need to do for this question is actually think about odds and evens and what combinations will give us, an odd number when we add them together. So, what I suggest is trying some numbers on the calculator. So let's try odd, add odd, add odd. 1 add 3, add 5. That gives me an odd number. So odd, add odd, add odd. Odd, add odd, add odd is odd. So that works. Let's try an odd, add an even. That doesn't work. Okay, so odd, add even doesn't work. And what the good thing we've got as well is that this is commutative, so it doesn't matter which one we pick in which order. Right, so what about if we have 2 even numbers? So 1 add 4 add 6. That gives us odd. So odd, add even is odd. And the only other option we've got is even, add even, which is going to give us an even number. So we've got 2 scenarios there, which will get an odd number with obviously three numbers. So odd, add odd, odd, add even. And obviously you've got any variation of evens and odds. So we could have had even, add odd, add even is odd. And you could have, again then, even, add odd is an odd number. Right, 3 counters are going to be taken at random from the bag. Find the probability that the total is an odd number. Right, we want the probability. So the probability of getting an odd and an odd and an odd is going to be, well, 6 odd numbers. So it's going to be 6 out of 9 to get an odd one first of all, times by, now if I take an odd one out, there's going to be 1 less odd in there, so it's going to be 5 out of 8 times by, again taking an odd one out, so it's going to be 4 out of 7. Let's see what that gets us. So 6 out of 9 times by 5 out of 8 times by 4 out of 7. That gives us 5 out of 21. Okay, now odd, even. Okay, what is the chances of getting that? So an odd number first of all, that's 6 out of 9. And you can see we're doing these without replacement, because obviously you can't take 3 counters out at once. In terms of probability, that's not how things happen. You take one out, then you take the other out, then you take the next out. So 6 out of 9. Then we're doing even, so 3, okay, out of 8, because we've got 1 less there in there now. And then another even is going to be 2 out of 7. So 6 out of 9 times by 3 out of 8 times by 2 out of 7. That is 1 over 14. Okay, and the next one is even, so that is going to be 3 out of 9 times by odd, so that's going to be 6 out of 8 times by, we've already taken an even one out, so it's going to be 2 evens left out of 7. And we should find, because we're just basically swapping around the numerators here, that we get 1 over 14 again. So 3 out of 9 times by 6 out of 8 times by 2 out of 7 is 1 out of 14. And then the last one we've got is even, so 3 out of 9 times by 2 out of 8 times by 6 out of 7. And again, that should give us 1 over 14 again. 1 over 14. So they're all the different options we could have. Now we just need to add them together. Okay, so 5 out of 21 plus 1 out of 14 plus 1 out of 14 plus 1 out of 14. The reason we're adding in this case is because I can have this scenario, or I can have this scenario, or this one, or this one. And when you're dealing with the or scenario in probability, you add them together. So 19 over 42 is my answer there. Now that's a question you can't easily check, and you've got to be careful to make sure you haven't missed any solutions or any other options to do it. So you might just want to go back and check again your working out. So could I have 2 odd numbers and an even? So 1 add 3 add 2. It doesn't work. That will always give me an even number. And obviously 3 evens, 2 add 4 add 6 gives me an even number. No. So I'm fairly confident that that is the right solution. Okay, next question. Okay, functions. F of x is x cubed, g of x is 4x minus 1. Find f of g of 2. Now what I like to do is put the brackets in between. So it's f, well, I'll do g of 2 first of all, and then plug that into f. So g of 2 is 4 lots of 2 minus 1, which is 4 times 2 is 8, minus 1 is 7. So then we do f of 7 is 7 cubed, which, if I remember correctly, is 343. Yeah. Okay. H of x equals f of g of x. Okay, find the inverse function. So what we need to do is do f and then plug g of x into it. Well, now g of x is 4x minus 1, so we're plugging 4x minus 1 into f of x. Now f of x is going to cube it. Now this is not going to end up particularly nice, so we're going to get 4x minus 1 cubed. Okay, now that is h of x. You could expand it, and having thought through expanding it, that is not the right way to go about this. And the reason I say that is because if we expand it, we're going to get x cubes, we're going to get x squareds, we're going to x's, and we're going to have a constant term. And then when we try to do the inverse, the usual way I do the inverse is write y equals, swap your x and y, and rearrange to make y the subject again. Now that's going to be very difficult to near impossible if you've got y cubes, y squareds, y's, and your constant term there. So I'm going to leave it like that. I'm going to let y equal to 4x minus 1 cubed, and then I'm going to swap the two. So I'm going to say x is equal to 4y minus 1 cubed, and then I'm going to rearrange it so I've got y as a subject again. So I'm going to cube root both sides. So cube root x is equal to 4y minus 1. I'm going to add 1 to both sides. So I get the cube root of x add 1 is equal to 4y. And I'm going to divide both sides by 4. So I get the cube root of x add 1 all divided by 4 is y. Now that is then my inverse function over here. So it's the cube root of x plus 1 all divided by 4. You could have it as 1 plus the cube root of x over 4 and so on. And we don't need to put plus or minus out the front here, because if you cube a number, if it's positive and you cube it, you get a positive answer. If it's negative and you cube it, you get a negative answer. So we don't need to do the plus or minus bit. Okay, that's that. Okay, so next question, 22, last question. Okay, we've got x squared plus y squared is 261. Now I know the centre of that is going to be 0, 0, and we can see that anyway. But it's x plus 0, y plus 0, so centre 0, 0, and the radius is the square root of 261. I might need that, I might not. A tangent to the circle is drawn at the point A with coordinates p, negative 15. Where p is greater than 0. Find an equation of the tangent at A. Now I'm just going to sketch on my radius. Now I know my radius is at a right angle to the tangent. Now I know that the point A lies on my circle. So if I substitute in my values, I should be able to work out the x coordinate and then get p. So x squared plus, well, y squared, y is negative 15 squared has got to be equal to 261 to be on my circle. So x squared plus, well, negative 15 squared, let's have a look at that. So that should be 225. So something at 225 is equal to 261. So x squared has got to be equal to, well, 261 take away 225, which is 36. So x is equal to plus or minus 6. Now it says here p is bigger than 0, so that gives us that p is equal to 6. Okay, so we've got this point here is 6, negative 15. 6, negative 15. Okay, now once we've got that, this is a much more straightforward problem, and actually this is one that you've probably practiced or may have practiced quite a few times before. And at this point it's actually nothing to do with circles and all to do with straight lines. We need the gradient here, we need the perpendicular gradient, so negative reciprocal, and then we need to just substitute in our gradient and our coordinates. So gradient of radius is, well, change in y over change in x. So I'm going to do, this is 0, 0 here, negative 15 take away 0 over 6 take away 0 is negative 15 over 6, which on my calculator gives me negative 5 over 2. Okay, that means the gradient of tangent is the negative reciprocal. So because that's negative, this is going to be positive, and the reciprocal basically flip the fraction 2/5. Okay, now from there, remember y minus y1, the equation of a line is y minus y1 equals m, your gradient, times x minus x1. That makes your life so much easier when you're doing this type of question, because all we've got to do now is substitute in the gradient and this coordinate here. So the equation of our line is y minus our y coordinate, so negative 15. If I subtract negative 15, I'm going to get plus 15, is equal to our gradient, so 2/5 of x take away our x coordinate, which is 6. So x take away 6. The gradient of that line is 2/5. I know it has to go through 6, negative 15. So plug in those points there, and we're done. Okay, that's the end of the paper. Like I always say, I hope that was useful. I hope it was helpful. You know, if there's anything you don't understand or anything you need me to clarify, please put it in the comments. You know, and as always, like I say at the start, like I always mention, like it, because that tells me that actually it was useful to you, and the more people this is useful for, the better and the more of these videos I can do. And then, you know, also subscribe, because I will be, you know, continuing to upload these up until the exams this year. And if there's anything else you would like me to go through, put it in the comments and I will make sure I go through it. I'll either reply to you with a, you know, a short brief answer, or do a video on it if, you know, it would require a video. Okay, right, thank you for watching, and I'll see you in the next one. Bye bye.